Copernicus's revolution rearranged the cosmos, but it did not rearrange Europe. His sun-centered system lived quietly in Latin nooks, admired for its elegance yet doubted as physical truth. Most scholars still trusted a stationary Earth, for nothing in ordinary life suggested that the ground beneath them moved. For the moment, heliocentrism held its authority. Yet the question Copernicus had posed, what if Earth moves, remained unresolved, suspended between courage and caution. Tycho Brahe entered this uncertain world with a determination unlike anyone before him. Born in 1546 and effectively orphaned after his father died in service to the Danish king, Tycho devoted himself to the sky. He built enormous pre-telescope instruments capable of measuring stars and planets with unprecedented consistency. Historians still debate the exact precision of his measurements, but the essential truth stands. Tycho recorded the heavens more carefully than any human before him. He did not embrace heliocentrism. Instead, he proposed a hybrid system, Earth fixed at the center. The sun circling Earth and the planets circling the sun. He preserved tradition, yet respected observation. Tycho was not a theorist. He was a custodian of data, guarding every number with near religious devotion. His records would become the turning point of astronomy. For decades after Copernicus, Europe remained hesitant. If Earth moved, why was there no physical evidence? Why did Scripture describe a fixed world? And why abandon the Ptolemaic model, which still predicted planetary motion reasonably well? Heliocentrism lingered as an elegant hypothesis with no definitive proof. What it needed was not a new idea, but a new interpreter, someone who could take Tycho's measurements and let the heavens speak for themselves. Johannes Kepler arrived in Tycho's life as a brilliant, restless mathematician. Their personalities clashed, but after Tycho's death in 1601, Kepler inherited the treasure Tycho had protected above all else: decades of precise planetary observations. Kepler began with loyalty to Tycho's Earth-centered system. The numbers disagreed. He tried the Ptolemaic model. They disagreed again. Finally, he tested Copernicus, not out of faith, but as a last resort. The fit was closer, but still imperfect. Mars, especially, defied the ancient belief that planets moved in perfect circles. Kepler refused to force the data into inherited shapes. After years of calculation, he made a bold, almost unthinkable concession. Planetary orbits were not circles, but ellipses. With that single insight, the entire sky fell into order. Every observation, every point, every motion matched. From this revelation, Kepler formulated his 3 laws of planetary motion, the first true physical description of the solar system. For the first time, heliocentrism was not a philosophical preference, but a mathematical necessity. Kepler did not defend Copernicus because he wanted to. He defended him because the universe left him no choice. The transformation from Copernicus to Kepler was not simply a shift in models. It was a shift in how truth was discovered. Copernicus imagined a new cosmos. Tycho measured it. Kepler proved it. The planets had always moved as they do, but humanity had never before united imagination with measurement and let evidence outrank tradition. The Renaissance created the intellectual freedom. Tycho provided the data. Kepler had the mathematics and the courage to surrender himself entirely to what the numbers revealed. Earth was no longer the center. The sun governed the system, and the universe became a place governed by laws, discoverable, elegant, and open to any mind willing to question.